Today we're going to go over some quick tips to draw a quick sketch of a sinusoidal function. A sinusoidal function is sine or cosine. It doesn't include tan. Sinusoidal meaning it's from sine or cos, because cos and sine are the same graph, just shifted 90 degrees from each other or shifted pi over 2. So let's quickly review what we need to know how to do. So let's start with sine. We know sine starts at 0, and then for every 90 degrees, it goes up and down as we go around the unit circle. So make sure you look at previous handouts on this, right? Know these points. So it goes up to 1, then at pi, circle comes back to 0, then through 3 pi over 2, and then back to 2 pi. So there's our graph of sine. Want to know that graph really well, right? It has a maximum of 1 and it has a minimum of -1, and so do all these graphs. So we got to kind of keep in mind what that shape looks like, starting at 0, 0, starting on our axis, heading up, heading down. Now, if the a value in front is negative, right, so that's our vertical stretch, it can cause a vertical reflection. So we're focused on the vertical reflection when it is negative. So all that does is it flips all the coordinates, right? So if you get to know this one really well, it's the exact same graph, just flipped upside down. We got a vertical reflection there, just flipping all the negative coordinates positive and all the positive coordinates negative, right? All the outputs of sine. Okay, so get to know those two graphs really well, because if you recognize the negative one, you can quickly find some answers and certain things that we're doing here when we're determining equations, graphing sketches, etc. Okay, let's do cosine next. So cosine starts up at 1, right? Top, heads to the axis, heads to the bottom, back up, and then to the top again. So it's the same, but we're just kind of seeing it 90 degrees later. Like if we had started right here, that would match with our. So notice how, not the best, but there we go. So notice how this piece here, right, matches this piece, right? And then they just continue on. So they're the same graph, just shifted 90 degrees. Because if we took this graph cos and we shifted it this way 90 degrees, we'd end up with sine. And vice versa, if we took sine and shifted it back 90 degrees, shifted it back pi over 2, because that's 90 degrees, we'd end up with cos. Okay, the other one you want to know is if the a value is negative, vertical reflection here, right? So if a is negative, vertical reflection, so flip it. So if you get to know these 4 really well and spot them, you'll have a much easier sketching these. You'll have a lot easier time doing any of the word problems we're going to do. Modeling graphs, especially when we get into modeling these graphs, which is, coming up with the equation given the sketch or given a word problem. These 4 are the essential 4. So it's really just sine and cos, and then if you can recognize when they're flipped, you're good. So really get to know. All right, let's have a look at the transformation. So let's start by having a look at the 4 transformations that we would perform. So we're going to be performing them on, like we said, sine or cos. Here's sine, here's cos. And there's 4 transformations, sometimes denoted by the letters A, K, D, and C. So here we go. Now, what we're going to start with, though, is just the transformations that affect the y coordinates. And that would be A and C. So they're easy to spot because notice they are outside the function. So when we say outside, this is the function sine, right? And look what's inside of it. What is sine applying to, right? A sine applies to all of that. The A and the C are outside the function. So we know these, we've seen them before. A is our vertical stretch, and like we said before, if it's negative, it causes reflection. But let's start with the C. So let's look at our vertical translation or displacement here. So you might hear different phrases, displacement or translation, basically meaning movement. So this moves our entire sketch up or down, as you can see in this little sketch we have on our handout. So in this case, it's 1, 2, 3. We'll say it's 4 units that it's been moved up, right? So in that case, C would be plus 4. So normally we would add that to all our y coordinates at the end, but it's actually where we want to start today. So the first thing we generally want to do is draw where our equation of the axis would be. Our middle is going to be wherever we've moved that C value up or down, right? So if that C is positive, move it up. C value is down. It starts at y equals 0. That's where it would be, like right here. And we move it up or down. The second thing we want to do is figure out where our maximums and minimums are at of our graph. So what's the highest it goes, the max, and what's the lowest it goes, our minimum, affected by our a value, right? If a is something greater than 1, 2, 3, 4, it's going to multiply those y values and stretch it. So in this let's say it's 1, 2, 3, 4. Normally it's 1 high is our maximum, but now it's 4 high. So A is probably 4 in this case. And same thing here. Notice that it's 4. So that's our amplitude. Now, when we talk about the amplitude, we always make it a positive number. So even if it was negative, that negative might flip our graph. Perhaps it'll draw it like this instead, right? Upside down. But the amplitude would remain 4, even though I haven't made it actually 4 here. I've done a terrible job. So something like this. There we go. So if it's negative, it causes that reflection, right? Vertical reflection if it's negative, and we just draw the upside down version of our graph. And we're going to multiply all the y-coordinates. But instead of doing it to every point, what we do is we just find where that middle is, the C value here, and we're going to denote, mark where our top and bottom are. So let's go try this on. Okay, so I've got a function here I've just made up on the spot, and it's a sinusoidal function. It's sine, as we can see here. Let's identify the A and the C values. So here they are in the back, right outside of our functions. A is 2. That means we have a vertical stretch by a factor of 2, and C is 6, right? So that tells us everything's moved up 6. Now, the secret here is we want to draw our axis somewhere on this graph paper. So we want to put it at 6. So that would be our middle. So our middle of our graph is going to be at 6. And the amplitude here tells me how much higher and lower I have to go from 6. So the highest I'm going to go is 6 plus 2. So the highest I would go is 8. And the lowest I'm going to go would be 2 below that, right? So it would be 4. So right there, I already know when I draw my sketch, it's going to be going between, right, 8 and 4. So let's come up with, on our grid paper, let's come up with some sort of scale here and draw our. Okay, so I'm just doing a rough sketch here for now, and then we can kind of neaten this up as we get going. But for now, I'm not going to draw in exactly where my y-axis is going to be. I'll figure that out in a bit. But for now, I'm just going to do a scale of 1 to keep it simple. If you want to count by 2, 2, 4, 6, 8, you could do that. The graph will be a little more compressed, but it'll be fine. I'm just going to go 1, 2, 3, 4, 5, 6, 7, 8. Sloppy right, and there's 0, right? So right there, that's where our y-axis would, or x-axis would normally be, right there, right? That's my x-axis. We're going to just start there. That's safe, right? X-axis, there we go. So my middle is going to be at 6. So I'm going to come up here and I'm going to draw my axis. We definitely want to draw that in. So let's just draw this axis in at 6. So right about here, right? So I'm just going to draw a dash line for my axis. If you got a ruler, make sure you use that. I know I'm freehanding all this here. So like we said, 6 is where our axis is, which is just y equals c, so y equals 6. Okay, we know the highest this is going to go because of our vertical stretch is 2 up and 2 down from there. So let's just, now some people you don't have to draw on your maximum minimum. I want you to draw your axis in the middle. But I would recommend to take your ruler and just quickly draw a dash line across, right? There's our maximum, 2 up. There's our minimum, 2 down. So we know our graph is going to be drawn between our maximum and minimum, right? Now you don't have to write max each time. Write it here. Maximum is y equals 8. Minimum is y equals 4. Okay, so that's easy to find, right? C value, and then you add and subtract your amplitude from that. Now, the thing is, we're going to be drawing sine, right? So we got to remember what sine looks like. Sine starts on the axis. Now, where we're going to start, we're going to go back and figure that out. But we know it's going to be going up and down between maximum. I want to make sure I'm actually touching it. I'm doing a sloppy job here. But touching the maximum, touching the minimum, we're going to get a wave, something like that. Let's have a look how to figure out where to start this wave. Okay, we're back looking at our notes here, and now we're going to look at the transformations that affect the x values. In other words, what affects our horizontal movements and transformations. So we're going to be looking at the k and the d values. So those are inside the function. So like we said before, those are what the function is applying to. Here's what's inside the function, right? Because cos applies to this, sine applies to this. So they're easy to spot because they're not on the outside. And we've seen these kind of transformations before. So how do you want to tackle those? Well, there's a pretty easy way of going about it. First, where is our graph going to start? So if we look back at our sketch, let's say we have to draw sine here, right? Now, normally sine starts at 0, 0, right there. But if there's been a horizontal shift or horizontal translation, it moves it to the right or left. So that shift is denoted by the variable d. whatever that shift is, that's where it's going to start. So let's say D happened to be equal to pi over 2, right? Or negative pi over 2, we'll say. Right? And then we'd change it to a positive. We'll go see that in a minute there, depending on what's in our bracket. We would shift and start here. I get the same picture, but pi over 2. So in other words, whatever that D value is, that tells us where to start our graph at. So the starting x coordinate is really easy to spot because whatever that D value is, right, that's where we're going to start at. So it tells us where to start. That's it. So in this case, there's a picture of rabbits and wolves. You know, the rabbit's starting at 0. Notice it's just been shifted. I'm not sure how much, but whatever that shift is that's going on there, that would be that value of D. So that's what we want to start with. As soon as we spot that number, cool, that's where we start. The final part takes a little more math, but nothing too complex, is the period. How much has our graph been stretched horizontally or compressed horizontally, right? So that all comes down to K. So remember, we always use 1 over K. And we're going to go 1 over K times our period. So the normal period of one of these graphs is 2 pi, right? That's one full cycle around the circle. So when we go around the unit circle, it takes us 2 pi to complete the circumference of it. So what we're going to do is we're going to times by 1 over K to perform that transformation. So that's how you end up with 2 pi over K. So basically, what is K? Flip it and multiply it by 2 pi. So that'll tell us how long it is for one period. So maybe our graph gets wider or maybe it gets more compressed. And I'm going to show you how you can use that to divide your graph up into quarters and figure out where all your key points go. All right, so let's identify those values. So right here is value. Now don't forget that when we're working with these, we really want to make sure that this has been factored. So this one's already factored for us, but it has to be factored, right? So we have to have that K value out front, and then that leaves the D value. So in this case, K is 1/2, right? And D is positive pi over 4. So we take that opposite sign from what we see because it's x minus the value of D. All right, so K is 1/2. That means what we really want to do is work with 1 over K. So we always flip that, right? So 1 over K is going to be 2. All right, so what does that tell us? Well, first of all, we are going to be starting our graph pi over 4. So that is going to be our starting location. So I'm just going to go down here. I don't know exactly where I'm going to put 0 at, but for now, let's say here's where pi over 4 is going to be. All right, so there's going to be my starting point, right? Now, how far apart should each point be from one another? Normally, if we look at our original one, right? Normally our graphs are pi over 2 between each key point. So, try to get rid of all this stuff here. So normally, as we jump from point to point, right? Like from here to here, 1 pi over 2, half pi, another half pi brings us to pi, another half pi, that's 3 pi over 2, and another half pi brings us to pi. Normally, we're counting between our key points 1/2 pi each time, right? And once you get to 4 halves, 4 times pi over 2, right? That gives us 2 pi, one full circle. So that's the regular one. Now, that's either going to get bigger or smaller. So the secret is, let's figure out what it is first, and then we're going to divide it by 4, just like here. So if I took 2 pi, I divide it by 4, I get each was pi over 2. That would be the distance between each key point. So let's go give that a try on ours right here. So we're going to start at pi over 4. Now let's focus on figuring out what the heck our period is. So we need that period is equal to, so the period is equal to 2 pi by k, which is, like we said before, it's the same as times 1 over k. So really, you just want to take, what's 1 over k? It's 2. So we're going to multiply that by 2 pi. So we just got to be careful here. Pi times 2, which means it's 4 pi. So that's our period, twice as long as it usually is. So normally it's 2 pi is what it takes to finish one cycle of this sinusoidal function. Now it's doubled. It's 4 pi. All right, so this won't be very hard. What we're going to do is, here, let's just erase some of this here. Let's see. So that's our, we'll just write that down there. That's our period. So we're going to start at pi over 4. Now, where's our endpoint going to be? Let me just jump to a new page. So we'll move down the page here. Okay, so let's just focus on this, right? Pi over 4 is our starting point. That's where we're going to start. So we've already figured that out. That's easy. That's our D value. That's where our cycle is going to begin. Okay, so now what we're going to do is we start there. Where are we going to end? Okay, so the end is going to be the start of pi 4. It takes 4 pi to this whole thing, right? So we need to add 4 pi plus pi over 4 to figure where the end of this is, because that's going to be our period, 4 and what? So that's easy. Again, when you're doing it, just think about it with 4 plus a quarter, right? 4 plus a quarter is just 8 plus 1 over 4. It's 9 over 4. So if we're working with pi, it's the same thing, right? If I get a common denominator of 4, this would be 8. Oops, actually it's 16. I see that there, dummy. 16 over 4 plus 1 over 4, so it's 7. Same thing here. 4 times 4 is 16 plus 1 is pi. So it's going to end up being at 17 pi over 4, 17 over 4 pi. So that's where my graph is going to end, right? So I've got to start there. I know the end has to be somewhere at 17 pi over. All right, so why don't we count by pi over 4s? Like we got to come up with a scale. Pi over, generally what you want to be counting by when you're writing the scale for these, it's the most part if you want to keep it simple, count either by pi over 4s, quarter, which is the same as counting by 45-degree angles, or count by pi over 6s, which is the same as 30-degree angles. Count out 17 pi over 4. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17. All right, so there's where my graph's going to end at. 17 pi over 4. There's one cycle of that thing, right? All right. Now, let's take this and cut it in half, right? Like let's cut pi over 4 in half, cut it into quarters even, right? So we've got pi over 4, right? Or sorry, 4 pi. That was our period, right? Let's cut it in half and then cut it in half again. So let's cut it into quarters. So what does this thing divide by, right? Each segment's going to be pi. So we have 0 to pi to 3 pi, oops, to 4 pi. Normally what we'd be counting by, right? If we cut it into quarters, because 4 pi divided by 4 sections is, so each one is a pi. 1, 2, 3, 4. The only thing we got to do is we just add pi over 4 to each of these. So we already have 0 plus pi over 4 because that's pi over 4, right? That's our starting point. Cool. So we got that. We already figured out the end point. That's easy. Right? We just did it. This guy plus pi over 4 gave us 17 pi over 4. So that's our endpoint. So we got that. Let's just find the other ones. So let's do 2 pi. Right? Let's 2 pi plus pi over 4. So again, get a common denominator of 4. 2 times 4 is 8. So I got 8 plus 1 pi. That's going to give me 9 pi over 4. So there's my middle, right? At 9 pi over 1, 2, 3, 4, 5, 6, 7, 8, 9. Now again, we could have just counted over, wait, we got 1, 2, 3, 4, 5, 6, 7, 8, 9. I thought like I missed it by 1 there. 9 pi over 4. Now again, it's just the middle. We could have counted like 1, 2, 3, 4, 5, 6, 7, 8, right? And then 9, 10, 11, 12, 13, 14, 15, 16, right? Halfway between my end and my beginning. And then let's do the other ones here, right? Now, again, you could probably figure this out a little quicker than me once you roll. So we got this guy, check. Let's do pi. What's plus pi over 4, like a quarter pi. So again, just get a common denominator. So this would be 4 pi plus 1 pi. 4 plus 1, because there's like an middle right there, is 5 pi over 4. All right, so 1, 2, 3, 4, 5. So right there is where my 5 pi over 4 is. And I think we could figure out what the last one is. I mean, we're starting to notice a pattern like 1, 2, 3, or sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 is where our last one's going to be. So you can fill these out a little quicker. And again, how did I get 13? Well, let's just do 3 pi. What is 3 pi? Right, it's a quarter. Times that by 4, it's 12 pi, 1 pi over 4. So that's 13 pi over 4. Okay, so there you go. I've got this thing broken up. We have everything we need now to draw this, right? So we're going to be starting here. So what are we drawing? That's the main thing. We're drawing sine, right? So what does sine look like? Sine's the one that starts in the middle, up, down, and back. So we got to know that. So we're going to start right here in the middle, up, and down again, bottom, and back. And there's my graph. Just one cycle of it. So we'll just focus on one cycle for today. Tomorrow we'll extend a bit more. We'll add some domain restrictions on. But there you go. All right, so notice how this lines up. There's my 4, right? There's my 5 pi. There's my middle at 9 pi over 4, 13 pi over 4, and 17 pi, right? They all line up to those points. My period is the period that we said. From here to here is 4 pi, not 2 pi. It's normally 2 pi, but we've stretched it out horizontally, so 4 pi. We've just shifted everything pi over 4 over. right? So that means where's 0 going to be at? We got to draw on that pesky y-axis. Our y-axis is going to be right here because we're counting by pi over 4s. Again, use your ruler. I'm just freehanding this here. Right, there's 0 right there. So let's actually mark off first here. So 4, 6, and 8. Right, make sure we mark those. We want to make sure we actually have a scale that makes sense. Notice like 1, 2, 3, 4. We're good, right? 1, 2, 3, 4, 5, 6. So we don't want to skip. We want to make sure you have a legitimate scale here because half of this is, can you come up with a scale that works? Not just draw that function, but can you add an accurate scale like I've added to the x-axis? And let's add those details. There's our y-axis. So that's one cycle. I could continue it. I could keep going. We could do some more. If we feel like we've used too much space, we could have compressed these. And instead of stretching out to 1, 2, 3, 4 every one, we could have just used 2 squares, right? We could have instead gone, that's pi over 4, that's 5 over 4. We could have compressed it a little bit and made maybe better use of our space. All right, we're going to draw. Oh, before we do that, let's just say we change this function, right? What if we made it -2 in front of the sign? So now all we have to do is, if we know how to draw the original one, I would just draw it upside down like this. So look, this one I'm drawing in orange is what negative would be like. So if you recognize that, you can just quickly look, draw the negative graph just like that. It's the same thing, just upside down. All right, let's do one for cos, and then that'll be. Let's do one for cos here. Same thing, we'll try to move a little quicker now. So I've just got this drawn down here, my x-axis, right at the bottom here. So I'm just going to throw a couple arrows on it, label with an x. All right, and let's start with A, which is 3, and C, which is -1. So remember, you want to start with C. That's the middle, right? So the middle of my graph is going to be y equals -1. So that's the center of my graph. And from there, my amplitude A tells me the highest I'm going to go is 3 above that, and the lowest I'm going to go is 3 below that. So -1 minus 3, my minimum, is going to be at -4. At my maximum, -1 plus 3, my max is going to be at 2. Okay, so I'm going to go on here. I'm just going to count by ones again. And I'm just going to go, okay, this is 1, 2, 3, -1, -2, -3, -4. Okay, so I've identified where my maximum is going to be, actually at 2 right here. So I'm just going to draw a dashed line in, showing my max. And again, you don't have to write at the end maximum. I'll do that first. The maximum is y equals 2. The minimum is y equals -4. So that's the lowest my sinusoidal function is going to go, touching the maximum minimum. Move along here. Use your ruler. Y equals -4. Oh, and of course, I have to draw in that y equals -1 there. So that's the graph. So one you definitely want to make sure you draw in. I would strongly recommend max and min in though, because that's generally when people make errors. They don't draw in and they tend to overshoot it more than you might think you would. All right, so there, that's easy, right? Cool, we got that. All right, so let's erase this here. Oops. All right, so now let's deal with the variables that affect the x-coordinates. So the 2 and the pi over 3 here. So 2 is our vertical stretch. So we have a vertical stretch by 2, right? So that is our k value. So k equals 2, but we really want 1 over k, right? So 1 over k is going to be 1/2. And this is our value. D is equal to the opposite sign, -pi over 3. Oops. So that's where we're going to start. So that's our main thing. We're going to start at -pi over 3. So to keep things simple, I'm just going to go on my graph somewhere here. I'm just going to put it right here. Okay? And I'm going to say that's where negative is. So I'm just going to kind of throw it out there, see if it works or not. Maybe I'll have to shift it around a little bit. Why did I pick that way? Well, I'm on the negative side somewhere. Maybe I'll move it over here a little bit. Doesn't have to be that far. All right, so there's -pi over 3. Now, what are we counting by? We have to figure out our period. So our period is equal to pi divided by k, right? So 2 pi, which is the same as 2 pi times 1 over k. So in other words, it's 2 pi times a half, right? That's what 1 over k is. So you end up just getting the 2's cancel out. It's going to be pi. So that's our period, right? Pi is shorter, right? It's been compressed because normally it's 2. we've compressed it to pi, so we've reduced the period. It's going to be a more squished, compressed graph. Now, if you pi and you divide it into 4 sections, right, you're going to get pi over 4. Each of them is going to be 1/4 pi. So that's what we're going to have. We're going to have 1/4 pi, right? 2/4 pi, 3/4 pi, and then 4/4 pi, which brings us to pi. So if I'm breaking it up, that's where they're going to be, except I have to add to my starting point. Okay, so that's what we got to do a little bit of math below here. Not much, but a little bit. Okay, so let's figure this out. I kind of already laid it out above. So we know we're going to start at negative pi over 3. That's our starting. Usually we start at 0. So everything's been moved back, right? So now the next place we got our... Okay, so like we said at the outset here, our period, or a moment ago I should say, our period is 2 pi times 1 over k. So we just said it's 5 times 1/2. Sorry, I'm just coming back to recording after taking a break. It's continuing for you. So this would end, right? So there's our period. Now, that means normally from 0 was where we would normally start. Now that we've compressed it, usually goes to 2 pi, but we've compressed it to pi. So that's our, right? So if we cut that in half, we'd have pi over 2. Cut that in half, pi over 4. And this would be 3. So if we broke it up, we'd be starting at 0, pi over 4, pi over 2, pi over 4, and pi. If we drew cos, it would look something like this, right? That's what it would look like. Except we got to move everything. We have to move every one of these over, right? So we want to move everything over pi over 3 because it's moving negative pi over 3. So this d value, we want to move everything to the left, pi over 3. All right, well, we already have 0 is negative pi over 3, so that's done. Let's go to our endpoint here. What if I want to move this guy to the left, pi over 3? How am I going to do that? Simple. We're just going to go, what's 2 pi? Sorry, what's pi? Minus pi over 3, move it to the left. So this is the same thing as if you're doing a third. Well, what's 1 minus 1/3? Isn't that just 3 minus 1, 2/3, right? That's the same thing here. We have 3 minus 1 over 3 pi. So that's just 6 pi. All right, so that means that's where we're going to end at. We're going to start here at negative pi over 3, and we are going to end here, 2 pi over 3. Now, how it's going to work for this is kind of a pain. We got to come up with something that'll work well. So we really want to stretch these points out a little bit. So I'm just going to count by 3. And I'm going to go maybe every 3 squares. I don't know if that'll work out well or not, but let's just go 1, 2, 3, 0. So I added a third. 1, 2, 3. Let's add a third. Pi over 3. Let's go 1, 2, 3. Add another third. 2 pi over 3. So I've come up with a scale. I'm trying to stretch it out. So try to use up some of your x-axis. You don't want to crush all this in together. So in my scenario, every 3 squares is pi over 3, or 1/3 pi. Now here's the deal. Where's the halfway point between this? Because if we're going to draw cos, right, it's going to start at the top here, end at the top, right? But where's that halfway point? It's somewhere in the middle here. Right? What is that middle? Let's figure it out. So the middle is going to be this guy here, right? Pi over 2. Except we just got to add, or sorry, I should say subtract pi over 3. So this is kind of a tricky one. I've kind of picked the trickiest one we could do. So pi over 2, let's minus that initial value, right? So we just need a common denominator. 3 times 1, 2 times 1. It's just 3 minus 2, pi over 6, right? You have a 1 here. You just write it as pi over 6. All right, so that's where my middle is going to be now. So my middle is right here. Right? So that's where cos is going to hit the bottom. This is right. And then the middle of those, right, we're going to have to figure out, it's getting a little ugly here, isn't it? I think I could have picked a much better scale now that I'm looking at this, because the middle here of my scale, not too nice, right? Because we're going 1, 2, 3.5 squares from there, and 4.5 squares from here to here. So we're going to have to go 2 1/4 squares. I do not love the scale I've picked. So let's go 2 1/4 right there, and let's go 2 1/4 back from here. All right, so that's where it's going to hit the middle at. Again, I've chosen a pretty awful scale here. We'll do some better ones in class tomorrow, but see if you can come up with some half-decent ones. And I've also made the cardinal sin of, I didn't put them on my axis. I put them on my x-axis. It should be here and here. There we go, on my axis for my function. All right, so we go down. Back up. And there it is. Now, we know our middle is this guy right here. If I wanted to mark that point, right, we figured out down here, what was that, pi over 6? So that's where that is right there. Or if we want to label it here, if we needed to, you know, that's pi over 4, -4 down. Now let's just say we need these coordinates times. We are going to need them. So we might want to break our scale down a little more. You know, what is there? What is that guy there exactly? All I have to do, pretty ugly, ugly points. We just got to take these two and subtract pi over 3 from them. Okay, so let's do the same thing we did here. So pi over 4 minus pi over 3. Let's get a common denominator of 12. So that's going to be 3 minus 4 pi. So that is negative 1/12 pi, or just negative 12. So that's what this guy is, negative pi over 12. Those are, we're going to try to avoid that, but I wanted to show you kind of a tricky one here. 3 pi over 4 minus pi over 3. Thing, 12, multiply by 3, multiply by 4, so I've got 9 minus 4 pi. So that gives me 5 pi over 12. All right, so that's where those ugly points would be. So if I needed to mark them on my scale, that's that right here, right? This point here, what did we say it was? Negative pi over 12. And negative 1, and this one here is at, what do we say, 5 pi over 12. And also at negative 1 on our axis. So make sure you don't draw it on the x here, right? We want to draw it on this axis, the axis of our function that's been moved down. So obviously the y's are really easy to get. You know, our maximum, minimum, and our middle. Getting the starting number is really easy. The tricky thing is trying to come up with a half decent scale, right? So here's where it's time to draw y-axis. Here's my y-axis at 0. There we go. Put a y on it, some arrows on it. Boom, right? Maybe numbers to it here. 1, 2, 3, -1, -2, -3, -4. Get rid of this from here. So sort of some rough work. All right, so there's my graph. Now again, that's just one cycle. I could continue it, draw some more cycles of it. And not the most beautiful scale, but you can see the math I'm doing to figure out where each of those points is at. I'm just taking my period, whatever that period is, right here. I'm dividing 4, so I want to divide it into the 4 sections, the 4 kind of quadrants, not quadrants, but the 4 sections of my right. 1, 2, 3, 4, right? Those 4 sections. And all I got to do is once I figure out those 4 numbers, right? I got them here. Just minus whatever or add or whatever, or subtract that initial value to it. So that initial value was D. That's where we're going to start our graph at. Okay? All right, so start with that today.